Good morning. This is your stats sensei, Mr. Spensey, and we're going to go over the quiz on NormCDF, inverse norm, and central limit theorem. So, a soft drink bottle vendor claims that its bottles are normally distributed. That's going to be important. With a mean internal strength of 157. So we probably ought to not note that down. Mean equals 157. And a standard deviation of 3 psi. We'll be referring back to that several times. So consequently, I'm going to mark that 3 psi and that 157. So draw a graph illustrating the empirical rule for the distribution of bottle strength. You must show 3 standard deviations above and below the mean. You must clearly label the z-scores. So let's start with the z-scores because they're the easiest. So we always start at 0 with the z-score. And of course, we're going to have 1, 2, and 3, and -1, -2, -3. And we might as well, since we're here, go ahead and mark our percentages that are associated with it, which are 68% for plus or minus 1, because that is the empirical rule, part of it. And then plus or minus 2 is 95%. And then plus or minus 3 is 99.7%. All right, so that takes care of the z-scores and the empirical rule, but it also says you must give the actual values and show the standard deviation. Well, our actual mean is actually 157. The z-score was 0. And by the way, we should label that it goes to positive infinity and it goes to negative infinity. We don't want to forget that. All right, so that takes care of that part of it, but we need to address our standard deviations. And our standard deviation, they said, was 3. So we're changing by 3 each time. So this is 3, this is 3, and this is 3. And as we head down, we have that. So now we need to put in our actual values. So 157 plus 3 takes us up to 160, then 163, and then 166. Going down or going backwards, we're taking away 3 from 157, and we get to 154, 151, and then we're going to drop all the way down to 148. And that'll take care of problem 1. All right, problem 2. 84% of the bottles will have an internal strength that fall within the interval centered about the mean. All right, what interval centered about the mean? And they said 84%. So 84% lets me know I'm doing an inverse norm. And we need to be centered about the mean. So looking at that, we start off by drawing our graph. It's like, okay, there's our chart, but it's going to be 157. And they didn't say anything about z-score, so we're using our actual mean, which is 157. And we want 84%. So this means this shaded area right here in the middle is 0.84. And we're going to need a lower bound and an upper bound. We're going to need 2 values because we're shaded in the middle. Now, because they gave us a percent, this is an inverse norm. So INV norm. The first thing they're going to ask you for is the area, which is 0.84. The probability. Then they're going to ask you for the mean, which is 157. And then we're going to go back to our standard deviation, and that was 3 psi. Mean and standard deviation. Next thing it'll ask you is, are we going to do left, center, or middle? I mean, left, center, or right. And of course, in this case, we're doing the center because we need to be in the middle. So we're going to go to our calculator. We're going to go second vars, inverse norm, area 0.84, mean 157, standard deviation 3. Make sure center is highlighted. And we get 2 values, 152.78 and 161.21. and 161.21. Put those in parentheses, and it's a good idea to label those lower and upper. All right, the next question. Suppose the bottler randomly selects 36 bottles, so we have a sample size of 36 from the last 10,000 produced. Give the mean and sampling distribution of these sample means. Well, the mean is the mean is the mean, and our mean originally was 157, so it's still 157. Three B says give the standard deviation of the sampling distribution of the means. So here's that key word, sampling distribution. So the standard deviation of the population looks like this, but the standard deviation of the sample means is the standard deviation of X bar, because that's the sample mean, equals the standard deviation of the population divided by the square root of n. Well, they told us earlier that our standard deviation was 3, so it's going to be equals 3 divided by the square root of 36, which is 3 over 6, which is 0.5 or just 1/2. All right, so our standard deviation for the second one is, or for 3B, is 0.5. Number 4, what is the approximate probability that a randomly selected bottle has an internal strength between 158 and 165? Well, I don't see anything about, they didn't give me a percent, so it's not an inverse norm. And it says a randomly selected bottle. So that tells me my sample size is 1. If I'm working with a sample size of 1, probably best to go to a NormCDF. But here I have two values, 155.8 and 156.5. They're both below the mean. So I'll put one down here at 155.8. And the other one is a little further up, and we'll call that 156.5. And we want to know the area in between there, the probability something lands in between there. So we're going to go to a NormCDF. And my lower bound is 155.8. My upper bound is 156.5. I have a mean of 157. And if I look back, I'll find out that my standard deviation is 3. Once again, we need to label these. So this is my lower, this is my upper, this is my mean, this is my standard deviation. So going to the calculator, second vars, inverse norm, NormCDF, second vars, NormCDF, lower bound 155.8, upper bound 156.5, mean of 157, standard deviation of 3. And we end up getting 0.08923. And actually, we could have stopped it at 0.08. Did I say that backwards? I did write that backwards. We 0.0892, and we don't even need the 3, but it's 0.0892. I wrote that dyslexically. All right, number 5. What is the probability that a 120 bottle sample, hey, has a mean? So we're talking about the mean, so this is no longer just the mean. We're talking about the X bar strength less than 156.6. So 156.6 is here. And we're shading this way, and we're shading all the way to negative infinity. But here we have, they gave us a sample size. So this is going to be a z-test. A z-test, and the first thing it asks you for is the mean, which is 157. Then it's going to ask you for the standard deviation, which in this case is 3. Then it'll ask you for your X bar, and that's the 156.6. Then next thing it'll ask you for is your sample size, which in this case is 120. And lastly, it's going to ask you for which way to shade. It says less, so we're using the less than symbol. So here we go. Try to get that showing on the screen. All right, stat, test, z-test. Mean of 157, standard deviation of 3. Lower bound, X bar of 156.6. Sample size, oops, that's typed in wrong, 156.6. Sample size of 120. And we're shading to the left. And I end up getting 0.0720. All right, that's number 5. Number 6. What is the probability that the mean internal strength for a 20 bottle sample? All right, so we still have a sample size greater than 1. They didn't give us a percent. So this is also a z-test. And they want to exceed 158.1. So 158.1 is here. We're shading up. And remember, we always shade to positive infinity. All right. So, or that it goes to positive infinity in this case. Z-test, our mean is 157. Our standard deviation is 3. The X bar is the 158.1 where our shading. The sample size in this case was 20, and we can use 20 because they told us the underlying distribution was normal. And then we want to shade up and to the right so we have a greater than symbol. Stat test z-test, mean of 157, standard deviation of 3, X bar of 158.1, sample size of 20, greater than. Calculate, and we end up getting 0.0505. All right, number 7. What are the z-scores associated with the middle 94% of the data? You must give both the upper and lower bounds of the interval. All right, so the middle 94% is right here. This is 0.94. But they asked for the z-scores, which means we have a mean of 0, because z-scores have a mean equal to 0, a standard deviation equal to 1. We're looking for the lower and the upper bound. So, second vars, inverse norm. I need to write that down. Inverse norm. The area, 0.94. The mean is 0, and the standard deviation is 1. And we need to be centered. And once again, it's 0, 1 because we're working with z-scores. So this is the probability, this is the mean, this is the standard deviation. So putting in 0.94, mean is 0, standard deviation 1, centered. And we get negative 1.88 and a positive 1.88. And really, I should be writing 18807, but I forgot. So lower, upper, but take it out to 4 decimal places. So negative 1.8807 and positive 1.8807. So my question is, why are they exactly the same? Well, they're the same because it's symmetric about 0. So the upper is going to be equal distance from 0 as the lower. And once again, they are symmetric, so they'll have the same value. All right, so that takes care of scenario 1. So now we're on to scenario 2. In scenario 2, they forgot to tell you it's normal, but it is. So cell phones have a mean weight of 6 ounces. So the mu is 6. And we'll be coming back to that. With a standard deviation of 2.8. The very first question says, hold on just a second. I'm a little bit not quite ready. The first question says, give the mean of the sampling distribution of the means. Well, the mean is the mean is the mean, so that's easy. The mean is just 6. The next one, give the standard deviation of the sampling distribution of the means. Well, the standard deviation of the means is the standard deviation of x bar, which is the standard deviation divided by the square root of n, which in this case would be 2.8 divided by our sample size. Our sample size was 49, so the square root of 49. So it's 2.8 divided by 7, because the square root of 49 is 7. And when I divide that, I get 0.4. So my answer, the standard deviation of x bar equals 0.4. All right, number 9. What is the z-score associated with the bottom 15%? All right. Well, 15%, and we're at the bottom, is here. Now it's a z-score, so we know that our mean is 0 and our standard deviation is 1. They gave us a percent. Anytime they give us a percent, we're working with an inverse norm. Inverse norm, our area is 0.15. Our mean is 0. Our standard deviation is 1. So probability, mean, standard deviation, and we're on the left-hand side of our shading. We're on the left-hand side of our shading. So I go to the calculator, and we're going to go to second vars. So second vars, inverse norm, area of 0.15, mean is 0, standard deviation of 1. Make sure left is highlighted. And we get a negative 1.036. So basically, we just calculated this z-score, and we said, hey, this z-score is a negative 1.0364. And that makes sense that it would be negative because we are below 0. We're less than 0, so we should be negative. Number 10, what is the probability that a random sample of 30 cell phones has a mean weight of less than 5.5? Doesn't mention anything about percent, so it's not an inverse norm. So it either has to be a z-test or a NormCDF, but we have a sample of size 30. So since our n is 30, which is not 1, this is going to be a z-test. So we want to know the probability that it has a less than 5.5. Well, if this is 5.5, we need to be less. And we're shading to negative infinity. All right, z-test, mean is 6. Our standard deviation, well, our standard deviation was 2.8. That's what we said earlier. The x bar is 5.5. The n, in this case, was 30. And we're shading to the left because it's a less than. So let's plug that into the calculator. Stat, test, z-test. Mean, 6. Standard deviation, 2.8. X bar, 5.5. N is 30. Less than. And we end up getting a 0.640 or 16% for our probability. So 0.1640. Hold on for half a moment. Yeah, that is what I got. 0.1640, making sure is still getting consistent answers. All right, number 11. What is the probability a cell phone always weighs more than 8.5? Well, that's misspelled. That should be weighs. Didn't catch that. More than 8.5 ounces. Well, 8.5 is above 6. So we're looking for this. And it says a cell phone. So this means N is 1. And if our sample size is 1, this is going to be a NormCDF because they did not give me a percent. So NormCDF, lower bound 8.5, upper bound infinity, mean of 6, standard deviation of 2.8. So lower, upper, mean, standard deviation. When I go to the calculator, second vars, NormCDF, 8.5. Oops, lower is 8.5 because that's the lowest part of my shading. Then we're going to infinity, which is 9 raised to the 99th power. Our mean was 6, and our standard deviation is 2.8. And we end up getting 0.1859. All right, number 12. Number 12 says 9% of the cell phones will have a weight below what? First off, they gave us a percent, so this is going to be an inverse norm. So we know it's going to be an inverse norm, but a weight below what? Well, if they use the word what, we need to draw an X. Anytime they use the word what, we need to draw the X. So the 9% or 0.09, they said below, so it has to be below X. That means we're coming from this side. So this is 0.09. All right. So inverse norm. First thing it's going to ask for is going to ask for the area, which is 0.09. Then it's going to ask for the mean, which is 6. Then it's going to ask for the standard deviation, which in this case was 2.8. We need to come back and label those. Probability, mean, standard deviation. And in this case, we're coming from we're shaded on the left-hand side, so this is on the left because we shaded to negative infinity. So I go to plug this in, second vars, inverse norm. My area is 0.09, my mean is 6, my standard deviation is 2.8. We're coming from the left, press enter, and we get 2.2458. Number 13, within what range would the middle 75% of actual weights fall? You must give both the upper and lower bounds. All right, within what range must the middle 75% fall? All right, well, we know the middle 75% is going to be here. Because I gave a percent, we know it's going to be inverse norm. And we're looking for this lower and this upper. So inverse norm. 0.75, and they are actually looking for the actual weights. That means we have to use the standard deviation of 6, and we have to use the 2.8 for the standard deviation. The mean is 6, standard deviation of 2.8. So this is my probability, this is my mean, this is my standard deviation, and we are interested in the center. So with that said, second vars, inverse norm, 0.75, mean is 6, standard deviation of 2.8, press center. And I get 2.7790. And for my upper, I get 9.2209. This is my lower, this is my upper. All right, last problem. Last problem says draw a graph illustrating the empirical rule for the sampling distribution of the mean cell phone weights. You must show 3 standard deviations and below, above and below. You must clearly label the z-scores. All right, so let's go ahead and start with the z-scores because that's probably the easiest thing to do. So we have a 0, we have a 1, we have a 2, and we have a 3. We have a -1, we have a -2, and a -3. This is our mean. We know that this first part right here is 68%. We know that plus or minus 2 is 95%. And plus or minus 3 is 99.7%. So then we need to come to our actual values. Well, our actual mean was 6. But here we need to be careful because it says the sampling distribution of the sample means. Sampling distribution of the sample means. That means I have to use the standard deviation of X bar. And the standard deviation of X bar is the standard deviation divided by the square root of N, which in this case was 2.8 over the square root of 49. And when we solved that before, we got 0.4. If you just brought the 0.4 down because you'd already done that on part 8B, that's okay. So I'm going to put the 0.4 here because that's what I'm going to be adding and subtracting. And this first one will be 6.4 at 1 standard deviation. At 2 standard deviations, it's 6.8. At 3 standard deviations, 6.4, 6.8, 7.2. This is going to be taking away 0.4, which would be 5.6, 5.2, and then 4.8. So 99.7% are between 4.8 and 7.2, 95% between 5.2 and 6.8, and then 68% between 5.6 and 6.4. All right, I appreciate you watching and hope to see you on the next one. Study for your tests.